Can you find the numerical value of this expression? Pause to try. This problem may seem impossible at first, but once you use these three expansions, it becomes a piece of cake. Just watch. To solve this problem, the first step we do is combine these two fractions. We can do this by multiplying the first fraction by root 50 plus 7 over root 50 plus 7, and the second fraction by root 50 minus 7 over root 50 minus 7. Since these two fractions are both equal to 1, it means that the value of these expressions still remain the same as before. After multiplying these fractions together, we get two fractions with the same denominator. This allows us to combine these two fractions into one fraction. Moreover, we can further simplify our fraction to this. Next, we can use our algebraic identities to simplify our result even more. Let's start with the denominator of this fraction. We can use our difference of squares formula to simplify it. We take the value of a to be root 50 and b to be 7, allowing us to rewrite this as root 50 squared minus 7 squared, or 50 minus 49, which is equal to 1. Substituting this back into our original fraction, we get that the denominator equals 1, so it is redundant and can be removed. Moving on, let's deal with this part of our new expression. Notice how this expression is in the form a plus b squared, which is exactly the form of this expansion. We take a equals to root 50 and b equals to 7, allowing us to rewrite it using our expansion formula. After calculating the products and simplifying it further, we get the result 99 plus 14 root 50. Then, we substitute it back into our original expression. We can also do something similar for the remainder of this expression, using this other expansion. Taking a equals to root 50 and b equals to 7, we can rewrite our expression like this. After further calculation and simplification, we get the result of 99 minus 14 root 50. Again, we substitute this back into our original expression. Finally, we're able to cancel out 14 root 50 from this expression, as we both added and minus it. This leaves us with the value of 99 plus 99, which is equal to 198, and that's our answer. In summary, we first rewrote our expression as one fraction, then used our algebraic identities to simplify it. Finally, we cancelled out the square roots to give us the answer of 198. With that, I hoped you enjoyed this video and see you in the next one.